Welcome to Mr. Chalk's Revision Tips. In this video, we will look at
pressure in liquids and pressure. So pressure in a liquid is different at different depths. Pressure increases as depth increases. The pressure in a liquid is due to the weight of the column of water above. Since the particles in a liquid are tightly packed together, this pressure acts in all directions. So, for example, the pressure acting on the dam at the bottom of a reservoir is greater than the pressure acting at the top. So, liquids and gases are both called fluids because both are capable of flowing. So, the pressure in the fluids that are at rest act equally in all directions. Pressure increases as you move away from the liquid surface. So, this is seen in experiments where we go and make holes in buckets of water, and you can see that the pressure at the bottom of the buckets of water is higher than at the top. So in addition, the more dense liquids are, or more dense liquids exert a great pressure. So for example, the pressure recorded at the bottom of a test tube of mercury is greater than the same test tube filled up with water, which is much less denser. We can measure pressure of gases or pressure in general, and we can calculate this using the equation pressure is equal to the height of a liquid times by the density times by the gravitational field strength. So pressure being measured in pascals, height being measured in meter, density being measured in kilograms per meter cubed, and gravitational field strength being measured in Newton kilograms. So if we look at this example, so a stone dropped into a lake, so we're calculating an increase in pressure on the stone caused by the water as it sinks from 1 meter to 6 meters. So the way that we'll do that is we'd look at the change in depth. So the change in depth is 5 meters. Then we'll plug this into our equation, which would be 5, which is meters, times by the density. So the density of water in the equation is 1,000 kilogram meter cubed. And then we're going to times that by the gravity, which is 9.8, to give us a change in pressure of 49,000 pascals. So if we look at a second example, so a person swims from a depth of half a meter to a depth of 1.7 meters. So the density of water is 1,030 kilogram meter cube. If we're looking at calculating the increase in pressure on the swimmer, we're going to go and look at the increase in depth, then plug that into our equation, which would give us an increase of 12,112.8 pascals. If we look at this second example, so figure 1 shows a container filled with water. The 3 holes in the side of the container are sealed with rubber stoppers. The water exerts a force of 27 newtons on the bottom of the container. The cross-section area of the bottom of the container is 0.009 meters squared. So we're calculating the pressure exerted by the water on the bottom of the container. We'd go rearrange our equation. So pressure would be the force, which is 27 newtons, divided by the area, which means that the pressure would end up being 3,000 and the unit would be pascals.
Thanks for watching.